Welcome back to another hair groom brainstorm in which we talk about the ideas needed to create this fourth iteration. So here we can clearly see that the individual hair curves have been replaced with these braids. And to get these braids, we could choose to use the other solutions in which we artistically controlled curves and draw out the actual pattern of the path of these braids. Or we can use a powerful system, which is a powerful node that has been included in Houdini, which is called the L system node. So to explore that node, let's just dive into this fourth iteration brainstorm. Okay, so I've placed down an L system node. It's really important to take a look at the documentation to see the full information that has been presented here if you can't buy the book, the textbook that teaches L systems. But L system is a node that creates fractal geometry from the recursive application of simple rules. The simple rules you could find more into these turtle commands, but L system was originally made by Lyndon Meyer, a computer scientist who in the 80s created this pattern to make imitation of plants. But we're going to use it to draw out curves in which we can use, just as any other curve, to replace hair guides, which if you add the skin prim and the skin prim UV, you'll be able to do as such. So here I have an example of just a line in which I move forward and I turn right. Now, where do we get this? So if I was to go into this tab, all these tabs here, in the rules tab, I have all these rules written here, but this actual carried out function is in the premise. So I'm going to just explain what some of these letters mean. So this F is move forward, and you move forward by the step size, which in this case is a 1. Okay, we have other variables that are available to move forward by. You can assign anything here and then procedurally drag on the sliders to control those values. But right now I have move forward and then do A. Well, A is a variable that I can assign. So in my first rule, I decided that A would equal a plus and then an F, and then the F travels by the variable C. A plus symbol in L systems means to turn right. So now if we take a look at this one here, I have now turned left. And that was because I move forward and then reference B, and B said negative. If I want to tip up and come in the Z towards the screen, that would be a hat. And if I want to tip down, to pitch down into the screen, moving away from the view of the user, then that would be an ampersand. So I'm going to take a look at all those lines merged together. And we have these 4 directions, and I'm going to paste on to the initial starting point a test geometry rubber toy. Okay, and with this rubber toy, I can demonstrate, here we have moving in these coordinates. With these commands, we have turn left, we have turn right, using these symbols in the code, turn up into the screen, turn down, and the rubber toy is facing in the original direction orientation that has been placed when it was first dropped here. But if I put on this orient along curves, this is very useful, we could see that now the toy is going to be moving along the line and facing in that direction. So using the carve node, I'm going to shorten this line by controlling the U. And there we have it. So he's moving along, but then the rubber toy turns and faces that end direction that it turns. This is very useful to understand how we can place objects along the curves if we were to place objects in our groom, such as maybe some hair ornaments later. Now I'm going to move on, and I'm going to talk about how do we create a braid. So this is a simple idea. Once again, L system. We know that braid is 3 strands. And the 3 strands, they could be created using branching, which is something L systems can do. But if I had to add the syntax of creating a branch, which is putting something inside of a square brackets, let's say, for example, here, I'll put this letter E, which is a rule that I've written down here, which will do A, B, and then do E again. If I do this kind of branching, it's going to create quite a huge L system, but I'd rather have them each strand placed individually so that I can put a transform and move those back and forth just to adjust where they are in space. But let's just see what, for example, branching out and doing E does, and then maybe going forward again after that branch. Okay, so we have it here. It's moved forward. Nothing's happened. Why is that? Because E refers to itself, but it only refers to itself as many times as you have generations. So if I was to drag the generations up, well, there's that original branch, that main path, that F that happened after E, and E is now branched off and is doing something else. And as we continue to drag up on the generations, E just keeps going and going. The rules for A and B, which were at the beginning of the premise, as we could see here, A, B, B, they do not refer to any other variables, or any other rules, because the C is just like a constant. So an F we know is a command. So A and B don't refer to anything else. So they do not change no matter how many generations are grown. Whereas E refers to itself recursively. So you can probably see the usefulness in how we can take and harness this generations in order to grow out a braid over and over. So I'm going to put it back to generation 1, and I'm going to get rid of that extra command at the end with the branching in the forward. And there we have a start for one of the weaves. Now I have another one I've created here and another one I've created as well. And I want to bring them all together. This with a sweep node to put this ribbon along. This is the pattern that we want to try to create with a braid. To move forward, to cross once while the third strand does not cross, and then to move forward on the outside again, diagonal to cross again. And as we repeat this crossing pattern with this weave, and then reassign these lines, turning off the sweep, and reassign these lines as input curves for hair generation, we can use the L system, which can be recursively referenced using generations, to grow this pattern repeatedly as a braid, as you will see in the next final iteration, the fourth. I hope this helped you to understand the basics of some of the commands for L systems, and thank you for watching.